I gave you, did you see when you came in, you had this sheet? Okay. But what we did, and I want to rehearse a little bit, the problem here was to find the moment about the C, about point C. And the notation is very important. Are you with me? You want to stand up and stretch? Stand up?
Yes.
Okay. Deep breath. You guys, we need to make sure that we're using the right notation. So we're trying to find the moment about C. And where's the force go from and to? The force goes from point A to point B. So force from A to B is written as FAB. Should I write it as force 1?
No.
Should I write it as force 2?
No.
Should I write it as force B?
No.
Should I write it as force A?
Maybe.
Maybe. But how about if there are two forces coming off of A? Does it create a little confusion?
Yes.
Yes. On your exams, you want to make sure that you're clear. A lot of times you use subscripts that maybe have to figure out which force you are actually using. Don't use 1 and 2. Use where they're coming from and where they're going to. So if there were two forces shooting off at A, I'm not going to call it FA1 and FA2. Call it FAB and FAC. Right? Use the notation that's given so you're showing the direction. Okay? It's just clearer. Okay, so we wanted to find the moment about point C, and the force went from A to B. So our notation for our vector is going from C to A. Everybody's clear with that? We go from the point we're finding the moment about. This right here is point C. This is my RCA vector. It goes from C to A. Okay? Then we solved for what the force vector was, and we got this. And then we solved for what RCA was. Okay, and we wound up converting it to meters just so it's a little bit easier. And then we did this, and you'll notice that I already assigned the matrix cross product, how to use your calculator to find the solutions. And that's due next week. Okay. So I did it by hand, so I set up the I, J, and K. I put the two columns in. I went this way and then subtracted that way. And here are the values. So the moment about C was a negative I, a negative J, and a negative K. Does everybody have all those numbers? Remember we wrote it down on the board. So the first thing we did, and I'm going to, since I have a clean sheet, I'm going to do this here. I'm going to say the moment about C is equal to negative 118.8 I minus 23.8 J minus 99.0 K. And the units we were looking at is Newton meters.
Plus 23.8.
Say it again?
It's positive 23.8 J.
Yeah. Oh, is this positive?
Yes.
Everyone? Okay, thank you. Okay, so make sure everybody has these numbers down. You should have them from last week. Okay, this is really important. What you're doing is you're finding out the spin that this force creates about this point. And I found out that it has a negative x, a positive y, and a negative k. Now, I don't want the axes here to confuse you because you're finding the axes about C. So what I'm doing is I'm going to cross these out now because I want to make sure I don't get confused. I'm finding out the moment in the x through C, in the y through C, and the z through C. You don't have to cross out the X, Y, and Z, but just make sure that you're meticulous so you don't check doing the wrong, you're not checking the wrong axes. We are calculating the moment about point C. Danny?
When you found the total distance, it looks like you wrote 0.22 for x. It would be 0.25.
This is a 0.25, this was a 0.2 squared.
Square.
Yeah, right, because you have to square each one.
And why is it 0.25?
Because the first one was 0.2.
Yeah. I don't see that on the diagram.
Okay, so let's see. So we're going from A to B in the X direction. So going from A to B in the X, it's 0.2. You see? And then going from A to B in the Y, it's going 250. And then in the Z, it's 180. You're going to get better and better at 3D. Matt, is your hand up to
No,
the side?
I'm just practicing my right hand.
Great.
Flexing it.
Okay, so now I want you guys to get really comfortable about drawing spins. So what did I get here? A negative X spin, right? So look at my X-axis. Is this the way the spin is? Which way? It's the other way. So I need to draw it so it's clear. Does that look okay? So everyone look up here. You notice how here I left it blank, right? Because this line is in front of my curve of the drawing of the spin. Okay, draw in Y. Is Y positive or negative? It's positive. Does that look like the correct spin? It's coming out at us like this. The X is going this way. Okay, and what about the Z now? The Z I got a negative. So it's spinning this way. Is that right? Yeah, negative. Okay, so you need to be more comfortable about seeing how the spin is going to be. Okay, next, now we're getting on to Charlie's question. There are 3 ways to represent vectors that we learned at the beginning of the semester. What were the 3 ways to represent vectors?
Magnitude and unit vector.
Magnitude and unit vector,
Magnitude and direction angle.
magnitude and direction angles, and vector form. So which one did we get so far? Vector form. And how did we do this? How did we get this answer? We're calculating a moment. There are 2 ways to calculate moments, right-hand rule and vector. How did we find this answer?
Vector.
Vector, because we did this. The matrix cross product. So another way is magnitude and unit vector, but we don't use magnitude and unit vector with moments. We only do magnitude and direction angles. So how do I find the magnitude of this? How do I find the magnitude of a vector? Pythagorean's formula. Right? Isn't it Pythagorean's in 3D? And what does it come out to be? 155.9 Newton meter. Talk to the person next to you. How are you going to find the direction angles?
Whoa. You take the moment about the x over the resulted.
Yeah.
You just do how you would normally, the cosine inverse of the ratio.
Yeah, of the,
So does that make sense?
instead of the force, it's the moment.
Yeah, I don't really because that's what you do with forces. This isn't a force, this is a moment. It could be totally different. Sorry. It could be totally different. Where do you get off to? Toys! Wow.
That was, dude, I had a dreidel as a kid. That thing was so fun.